Back in 1977, two small spacecraft set off on what would become one of the greatest adventures in human history. Their job was simple to say and almost impossible to do: explore the outer planets, and try to understand our place in the universe. Nearly 5 decades and over 24 billion kilometers later, they're still going, now sending us signals from interstellar space itself. Hey everyone, James Vince here, and welcome back to Astrum Origin. Today we're diving into the full story of Voyager 1 and Voyager 2, how they were built, what they discovered, and the strange, almost human moments of crisis they've faced along the way. Let's get into it. Here's something strange: the tools pushing the edge of our solar system knowledge aren't cutting edge at all. Each Voyager probe runs on a computer with less memory than a car key fob, and they're still recording data onto magnetic tape technology from the 1970s. That's the reality of deep space travel. By the time your spacecraft reaches somewhere incredible, its tech is already ancient. Originally, neither probe was meant to leave the neighborhood of Jupiter and Saturn. Their 5-year mission was only possible because of a rare planetary alignment that happens once every 176 years. But once they nailed those first targets, NASA extended the mission to include Uranus and Neptune. And when even that was finished, they launched what's now called the Voyager Interstellar mission, sending both probes toward the very edge of the Sun's influence and beyond. So how did two machines from the disco era pull off something this ambitious? Smart engineering. Each probe carries a nuclear power source that converts heat from decaying plutonium into electricity enough, at launch, to run a laptop and charge a phone. It loses about half its strength every 87 years, but it was built to last well past 2025. The timing of the mission wasn't an accident either. NASA knew this planetary alignment wouldn't come around again for nearly 2 centuries, so they used gravity boosts from each planet to slingshot the probes faster and farther than their engines alone ever could. Every system had a backup. Literally 16 thrusters, 8 of which exist purely as reserves. That decision paid off in a huge way decades later, when Voyager 2's primary thrusters failed after 37 years of use. Its backups, untouched for 4 decades, fired up and worked flawlessly. Communication was its own challenge. The probe's antennas broadcast with roughly the power of a refrigerator bulb, so NASA's deep space network has to track their exact position just to catch a whisper of a signal from billions of kilometers away. And amazingly, the onboard tape recorders built to store the equivalent of about 100 photos never lost a single byte of data in service. Even getting past the asteroid belt was a gamble. Scientists once feared it would tear a spacecraft apart. It didn't, and thanks to Voyager, we learned that belt is mostly empty space. Voyager 2 actually launched first, in August 1977, with Voyager 1 following 2 weeks later on a faster path that let it overtake its twin before either reached the asteroid belt. Voyager 1's first photo, taken less than 2 weeks after launch, showed Earth and the Moon together in one frame, a quiet, almost emotional start to a mission that would eventually leave the solar system entirely. By 1979, Voyager 1 reached Jupiter, and the images stunned everyone. Scientists expected simple wind bands; instead they found wild turbulence, swirling storms, and a great red spot confirmed to be a massive rotating storm system, alongside other similar storms nobody had predicted. Voyager also caught proof of faint rings circling Jupiter, something only suspected before. But the real shock came from its moons. Io, expected to look like a cratered rock similar to our Moon, turned out to be the most volcanically active body in the solar system, its surface constantly reshaped by eruptions blasting material 100 kilometers into space. Meanwhile, icy Europa revealed strange surface cracks that hinted at something remarkable: a hidden ocean beneath its frozen shell. Next stop, Saturn, reached in 1980 and 1981. What scientists thought were 5 simple rings turned out to be hundreds of thin ringlets. Voyager found an entirely new ring, spotted small shepherd moons that keep ring particles in line, and photographed mysterious dark smudges on the rings that still aren't fully explained today, possibly caused by electrically charged dust. Saturn's moon Titan turned out to have a thick, nitrogen-rich atmosphere, the only place beyond Earth known to have one like it. And tiny Enceladus turned out to be spraying huge plumes of water vapor into space, a discovery that decades later helped inspire the Cassini mission to investigate further. While Voyager 1 bent away from the planets and headed toward interstellar space, Voyager 2 carried on alone toward Uranus, arriving in 1986. It found an almost eerily calm, featureless atmosphere, and a magnetic field tilted a bizarre 59 degrees from the planet's spin axis, nothing like Earth's mild 12-degree tilt. It also revealed new rings and moons, including the strange, fractured surface of Miranda, which looks like it was shattered and pieced back together. 3 years later, Voyager 2 reached Neptune, its final planetary target. It found ferocious winds faster than anything else recorded in the solar system, a giant storm nicknamed the Great Dark Spot, faint rings, and Neptune's icy moon Triton, complete with active geysers erupting nitrogen gas. Before Voyager 1 left the planets behind for good, mission scientists encouraged by astronomer Carl Sagan turned its camera around one last time in 1990 for a farewell photograph of home from about 6 billion kilometers away. The result became one of the most famous images ever taken, Earth reduced to a tiny speck of light, a pale blue dot suspended in the vastness of space. Sagan later reflected on that photo, describing it as a humbling reminder that everything humanity has ever known, every person, every event, every triumph and tragedy has unfolded on that single, fragile point of light. It remains one of the most powerful arguments ever made for taking better care of our planet. Leaving the planets was only the beginning of the next chapter. To officially exit our sun's bubble of influence, both probes had to cross through the termination shock, then a turbulent boundary layer, and finally the heliopause, the true edge where the sun's influence gives way to interstellar space. Along the way, Voyager data revealed that this boundary isn't a smooth line at all. It's messy, bubbly, and shaped by magnetic turbulence, forcing scientists to rebuild their models of how our solar system's edge actually works. Voyager 1 made that crossing in 2012, becoming the first human-made object in interstellar space. Voyager 2 followed in 2018. Strangely, both probes measured the surrounding magnetic field as almost unchanged, the opposite of what theory predicted, and yet another example of Voyager rewriting the textbooks. These probes are still working today, but not without hiccups. In 2022, Voyager 1 began sending back garbled, nonsensical data. After months of painstaking back-and-forth communication, each message taking nearly a day to travel one way, engineers figured out the spacecraft had accidentally switched to an old, faulty backup computer. Once they got it talking to the right system again, things went back to normal. Then in 2023, another onboard computer glitched out in a similar way, taking months to resolve. That same year, a routine command accidentally tilted Voyager 2's antenna just 2 degrees off course, enough to lose contact entirely. NASA managed to re-establish the link only by sending an extremely powerful signal from their most sensitive tracking dish, and waiting more than a day and a half to find out if it worked. Eventually, both probes will run out of power and go silent for good. But that won't be the end of their journey, just the end of ours listening in. Each carries a golden record loaded with sounds, images, and greetings from Earth, drifting onward through the galaxy for millions of years, long after everyone who built them is gone. And that's the incredible story of Voyager 2, tiny, aging spacecraft that rewrote what we know about our solar system and kept going long after anyone expected them to. If you enjoyed this one, make sure to like, subscribe, and turn on notifications so you don't miss the next deep dive. This has been James Vince, and you've been watching Astrum Origin. I'll see you in the next one.